All right, we're going to start with the first one. We're going to go over this, so if you didn't get it, that's okay. So the first one, this is in slope-intercept form. So who can raise their hand and tell me what would I plot first on this graph? We'll go for it. The 4. Would it be on the x-axis or the y-axis? The y. So I'll go up 1, 2, 3, 4, and plot that point if it works. Oh, it's frozen. 4. There we go. Then we can see that our slope, if there is no coefficient, what is the invisible coefficient? 1, right? And so I would know I would be going down because it's negative, and it's always over 1. So I would go down 1, over 1, plot. Down 1, over 1, plot. And then you draw a line that goes through those points. You always go to the right. Unless you can't fit it, then you would go the opposite direction, but we can fit it here. When we're doing our table, we know that our y-intercept is when our x is 0, right? So we know it's 0, 4. Let's find these points right here. So if it's going down by 1 and it's starting at 4, what's the next one going to be? 3. What about this one? 2. This one? This one? So today we're going to learn how to use a calculator to find our table, so a little cheat sheet method, and graph. So we're right here, we're graphing, then doing our table. Today we're going to be doing quadratic functions, but we're going to use our calculator to find the table and then graph it. The second one is actually just coming from your check for understanding from yesterday. And so it was, or your do now from yesterday. So it's x minus 3y equals 15. And remember, yesterday you converted from standard to slope-intercept form. So who can raise their hand if I need to get this in slope-intercept form? What's the first thing I need to do? Go over. Subtract x, and what would be the invisible coefficient next to it? 1 also. So I would subtract 1x on both sides. And you end up getting negative 3y. Can I combine these? No, right? One has an x, one doesn't. So I just rewrite it like this. A lot of people I still see combining on like terms. Make sure we're not combining. Then to get rid of that negative 3, I got to divide all 3 terms by negative 3. And when you do that, you end up getting y equals, what's a negative over a negative? Positive 1/3 x minus 5. So right here, I would plot negative 5 on my y-axis. This is really hard to see for some reason. 1, 2, 3, 4, 5. And since it's positive, am I going up or down? Going up. So I'm going up 1 over 3. 1, 2, 3. Try to do it on your paper better than I'm doing it on the board. I can't see it, but you get the general gist of it, right? You'll be able to see it on your other paper a little better. Then we knew our y-intercept was 0, negative 5. And we know we go up 1 over 3. So up would mean I'm playing around with the y's. The x's, I'd be playing around with the bottom one. And we'll be going over this as a table, so I'm actually going to start teaching you how to do the table right now. All you have to do, and you're going to have your calculator. Good question. The x doesn't always have to start at 0. But we're starting it at 0 right here because we can obviously see the first point is 0, negative 5 because it's our y-intercept. But it doesn't always have to start at 0. And so I'm going to teach you how to find your table using that calculator. So we're going to do it with this linear equation, then we're going to do it with the quadratics. So get your notes out for today. It says graphing quadratic functions. And there is no survival guide note for today. It's all in this book. Everybody has a calculator, right? Yeah. Cool. So to see a table, the first thing you're going to do is click the button table. So first thing you're going to do is click the button that says table. Does everyone see that button? It looks like, let me go to this right here. It looks like this button right there.
Which one? Table?
Yeah. So the first thing we do is click table. Does everyone see that?
Yes.
And so when you click table, it should look something.
Yeah.
Let me see if I can play this.
Now, once I'm done with the equation, I'm going to minus.
I just want you to see what it looks like on the screen. And so it should look something like that, where it says y equals. Perfect. And so we know we couldn't put our standard form equation in from our do now, right? Because it says y equals. That's why we needed to get it in slope intercept form. So now what I want you to do, I want you to write this equation down in the calculator. So where it says y equals, how do we get a fraction? What button do you press? ND, right? So press ND and put 1 over 3. The X button looks like this. So you table and then type in your equation. And instead of, doesn't matter which variable they use, there's a button right here that looks like this, and it has like a big X and some other letters around it. Let me see. It has X and then it has Y, Z, T, A, B, C. Do you guys see that button? That's what you're always using as your variable. That's step 1. This is step 1. So you click table, and then you type in your equation. So I would type in 1/3 using the ND button, X. And then the rest of the equation was minus 5. So ND 1/3 X minus 5. Then you're going to click enter 5 times. Yeah, you're going to click enter on your calculator like 5 times. Perfect. And then you should be able to see your table. Do you guys see it? So you can scroll and find any point using this table. Remember, you always get a calculator. And then fill in your table. So over here, we're going to use whole numbers because you can see some of them are in fractions because we have a fraction as our slope. So if we go all the way to 0, does everybody see 0, -5? Does everyone see it? 0, -5. The next time you see a y as a whole number is at 3. What is the y coordinate when x is 3? Oh, make sure, be careful, the biggest mistake, don't use -5, just use -5. Because it will get you a whole different answer. So at 3, you can see the y is -4. When you keep scrolling, you can see at 6, what's the y? -3. Yeah, we're just finding the whole numbers right now. At 9, we can see it's -2. And the next one is at 12, it's -1. So you can see the y's are going up by 1, and the x's are going up by what? And what's the slope? 1/3. And so you guys now always have this tool, right? You always are able to use this calculator. So we're learning how to use the tables, and from there, be able to graph. And so now we're going to try it. That's basically our lesson. We're going to try it with quadratic functions. So we're going to go to these notes right here. We're going to start with this right here. And so we can see that this is in standard form. For brain buff, who can raise their hand and tell me what's the one thing that I can find easily when it's in standard form, Jalen? The y-intercept. Beautiful. For a brain bug, Christopher, what is the y-intercept?
It's the code 5.
What's that called?
The code, the number 5 cell.
What's that called? Not coefficient. What's the other C word?
Coefficient.
You want to know? What's the other constant? Constant, right? That constant dag. So we know the y-intercept at 0. We know it's 5 without even typing anything in our calculator. We know at 0 it's 5 because that's our y-intercept. It's our constant. Now we also know if I were to plug in 0 for the x's, 0 plus 0 plus 5 equals 5. Yeah, you can sit here and plug it on the calculator. But I'm going to just start with that point because I know my y-intercept is 5. So now we're going to graph it in the calculator. Okay, so now what we're going to do, let's try to put this into our calculator. So we click first, what button do we click first? Table. Table. And clear out what's ever in there. So now you're going to click X. Type the equation in X, and there's an X square button. Oh, make sure you click this X right here. Yeah, click X, and then click X squared. Plus 4x plus 5. Does everyone get how to type it into your calculator? Then what do we do next? Press enter like 5 times. And you can see the table. So now let's scroll until we see -4. At -4, what is the y coordinate on your calculator? 5. At -3, 2. At -2. At -1, 2. Perfect. Does that make sense? Now, I want to also show you what it looks like when a vertex is on your table. Do you guys see the little bump right here? See how it goes from 2 to 1 back to 2? Do you guys see that? You guys see how it goes to a number, to a different number, back to that same number? This right here would be your vertex. That bump, because it's the lowest or highest point here, would be your vertex. See, it's well, let's look at it. We see our leading coefficient's positive. So would it be a positive Patricia or negative Nancy? If our leading coefficient is positive, if it's positive though. We know we're going to have a positive Patricia. There she is. So our vertex, would it be a min or a max? Minimum, right? So we know that this -2 or this -2, 1 would be our minimum. Now you're just plotting these points down. So -4 is my x. Then I'm going to go up to 5. Then I'm going to go -3 to 2. So I go to -3 on my x-axis and go up 2. I'm going to go to -1, 2. And then 0, 5 we already graphed. So it looks something like this. Do you guys see how we were able to do that a little bit easier using the calculator?
Yeah. What did you say you took the lowest?
Yeah, the bump, basically. So we look at our y values and we go, okay, it goes from 2 to 1 back to 2. That's always your vertex, that middle part. And so you want to make sure when you're doing it, these tables are filled in for you. Eventually, what you're practicing, they're not filled in. So you're going to have to practice figuring out where is the baby bump in the table and make sure that's in the middle. And I'll show you that after we go through these examples. So right here we have intercept form. So go to the next page. We're going to do these 3 together. So the next one's intercept form. Who can raise their hand for a brain bug and tell me what are we trying to find when we have intercept form? For brain bug. Raising your hand. Yeah, for them. The roots. What's another word for roots for another brain bug raising your hand?
Zeros.
Zeros. What's another word for zeros raising your hand? X-intercepts. What's another one for x-intercepts raising your hand?
Roots.
We already said roots. One more. It starts with S.
Solutions.
So So all those things mean the same thing. They all mean x-intercepts. So remember, if I can write an O with it, I know it's the opposite of what's in here. So what's the opposite of -3? +3. So I know that 3, 0 is an x-intercept of root, a solution. I know that's one of my x-intercepts. What's the opposite of 1? -1. So we know that's another x-intercept.
So you see obviously.
Yeah. So x-intercept through y is always 0. So I'm going to go here and put -1 and 3 because I know those are my two x-intercepts. Then let's type the rest in the table. So you type it just like that. Parentheses, x minus 3, parentheses, parentheses, x plus 1, parentheses. Yeah, you put the parentheses in. It should look exactly like how it is on here. So like this. Beautiful. Then click enter a couple times. Make sure it's -3, not -3. That's the biggest mistake I see. No, make sure it's -3, not -3. Because if it's negative, it will look a little bit different. Give me a thumbs up once you got your table. Awesome. So at 0, what's your y coordinate? -3. At 1, what's your y coordinate? -4. And at 2? Do you guys see where your vertex is here?
Yeah.
Where is it? Does everyone get how that's your vertex? Where it goes from a number to a different number back to a same number? That middle part is always your vertex. Who can raise their hand and tell me the y-intercept on this table for brain fun? Who can raise their hand and tell me the y-intercept for the brain fun? Here, you want to give it a try? No? Jalen? 0, -3. Because it's when your x is 0, that's your y-intercept. So now go ahead and graph it. 0, -3. I'm going to just graph in those colors. 1, -4. 2, -3. So it looks something like this. The last thing we're going to learn for today is sometimes they'll ask you when the function's positive and when the function's negative. So write this out right here. Positive, negative. You're always looking at the y values. And so we're looking at the y values, and we're trying to find when the y's are positive above 0, right? Above that line. And when they're negative below the x-axis. And so negative, when it's negative, that's this right here, right? Do you guys see that?
Yes.
This part, all the y's are negative. What's the x coordinate of this right here? -1. And we know it's touching it, but when it's touching it, that's 0. That's not negative. So that you're not going to have a bracket, you're going to have a parentheses.
Right.
So we know it goes from -1, and then when is it? It's negative until it hits what x coordinate? 3. But it's hitting, that's at 0, and 0 is not negative. 0 is not. For positive and negative, you usually don't put a bracket. Usually you're just putting parentheses. Positive, we know when x is less than -1, or when x is greater than 3. Because when x is greater than 3, we know it's positive. And when x is less than this one, we know it's positive also. And so when they're asking about positive and negatives, and you can even see it on the calculator, right? You can see that after x is 3, you can see the y start to get positive. So always use this will never be an open-ended question. It usually will always be like a multiple choice. but the calculator and table can help you come up with these answers. Okay, let's do this last one, vertex form. And so here we can see the vertex. For Brainbuck, who can raise their hand, and you can cash in Brainbucks today for candy. Who can raise their hand and tell me what the vertex would be reading this? So remember, it's the opposite of something and the same as something. Someone besides Jalen, because I know Jalen got it. Someone besides Christopher, because I know Christopher got it. Someone else. Selena, you want to give it a try? What's a vertex? Beautiful. -2 because it's the opposite. I know you have Jalen, but I want to see something at it. -2 because remember, if I could write an O, it's the opposite of that sign, but the same as this one. So -2, beautiful. -4 would be your vertex. Awesome. And we know it's concaving up because it's a positive projection. So you know that point is going to be your minimum. So I'm going to go to -2, -4, and 5. To see the rest of it, let's go look it up on our table. So this is like looking for an app on your little iPhone, right? These are your new little iPhone, whatever number is out this one. These are your new little phones. So it's almost like you know where your app is, right? You know where Snapchat, Instagram are. You know what folder it's in, right? You're trained at this point, so click, 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 click. That's what I want you to be like on this calculator. So, what's the first button we need to click to see the table? Table. Clear it out, and then we're putting exactly this, parentheses, x plus 2 squared minus 4. And click enter 5 times. And then fill in your table so you get how to. Now start filling it in. So do you guys get how you can always use this calculator as a cheat sheet too? Like if you can't find the vertex or you forget how to do it, you can type in the equation and just find the bump. And you know that's the vertex. So you can always, I always call my students to use the calculator as a little cheat sheet. For a brain bug, who can raise their hand, tell me, looking at the table, what are the x-intercepts? Fernando, go first. Perfect. -3 or -4, 0, 0, 0. Selena, what's a y-intercept?
Is the
I'm calling you. Not -3. Jalen, what is the y-intercept? What's a y-intercept? 0, 0. It's also, and it's your x-intercept, it's also your y-intercept. Who can raise their hand and tell me the vocabulary word for 0, 0?
Origin.
Fernando, good job. You've had so many brain bumps today. I'm proud of you. So, origin is also what 0, 0 is. So these are your two x-intercepts. It's also your y-intercept because the x is 0. So let's plot those right here. So 0, 0, -4, 0. And then fill in the rest of your chart. So -3, -3. It looks like this. Last thing we're going to do is positive and negative. So between what two x values, the easiest is to figure out, okay, between what two x values is the function negative? Who can raise their hand and tell me what is, between which two x values is the function negative? Anyone want to give it a try? Between which two x values is the function, are the y's negative? And so, even look here, right? We could see, when are the y's negative? All of these y's are negative, right? And so between which two x values are they negative? What's this x value right here? -4. So between -4 and 0. So those parentheses mean it's below that because 0 isn't a negative number. It's positive when when x is smaller than -4, right? Because right here, all the x's are smaller than -4, and when x is larger than 0. Does that make sense with positive and negative? All right, I'm going to do one more with you where now you're going to have to fill in the chart and fill in these things. So I'll do one of these with you. But I'm going to give you a few minutes. So you're putting your table in. You know that this is in vertex form, and the vertex should always be in the middle. So does anyone want to try for a brain bug to tell me what is the vertex of this? So we already did it, but I want to see. Christopher, go for it. 3, because it's the opposite. So I'm going to put 3 in the middle and +4. So I know my bump's going to happen at 3, 4, right? And so right here, if I go to 3 and then up to 4, I know that's going to be my vertex. Is that going to be a max or a min? Looking at your leading coefficient. It's a min. Well, is it negative Nancy or positive Patricia? Negative Nancy. Look at her frown. Does she have a min or a max? A max, right? So we know that point is going to be the highest point. Now go fill in the rest of the table. Type the equation in. Practice finding your, new snapshot app. It's called the table. Yeah, now you put a negative because that sign in front is a negative. And then I would start at your vertex and then do like 2 and 2. You can fill in the whole thing if you want, but I would start at 3, 4 and do like 2 numbers after it, 2 numbers before it. Maybe we'll do 1. Yeah, we're going to go over it. But domain's always the same if it has arrows. What is it always? What? Yeah. So at 0, what did you get the y was? -5, 0, 3. Beautiful. See how it almost looks like a little mountain? You can even do 6 and you can So you don't have to do all these each time, but I want you guys to see what are the 2 zeros here? 2 x-intercepts. Anyone know? Which one are the 2 zeros or x-intercepts? What are 2 x-intercepts here? It's when your y value is what number? 0. When is your y 0? 1, 0, and 5, 0. Those are always your x-intercepts. So right away, I know 1, 0, and 5, 0 are going to be my x-intercepts, which makes sense, right? Because it's looking like a little mountain. What's your y-intercept? It's always when your x is 0, right? 0, -5. And then you can just plot the rest of it back. So we know it's 2, 3. And then we know this. And so this positive and negative is going to look a little bit different. So we know our form is in vertex form. And I'm going to start down here, positive. Positive is going to look a little bit different because now positive is going to be between 2 x values. See, it's only this part is positive. Between which 2 x values is the function positive? What's this x value right here? 1. From 1 to 5. And that's because now we're dealing with negative Nancy. Before we were dealing with positive Patricia. Now we're dealing with negative Nancy. It's negative when x is less than 1, right? Because all these x's are less than 1. And when x is greater than 5. So it's always going to look something like this. Or it's less than this one and greater than that one. This would be switched, where it would be an interval. Like if it was going like this, you would know it would be an interval, but it still would look something like that. Just the opposite. Positive and negative. Does this have a min or a max? Max, right? That's the highest point. What is its max? What's the y coordinate? 4. So it's y equals 4 is your max. We also know that's your y coordinate of your vertex. What's the x coordinate of your vertex? 3. That's also known as your axis of symmetry, right? So that x coordinate of your vertex is your axis of symmetry. X equals 3. Domain is always the same. What is it, Fernando? What's domain? You're the one that said it. Because the arrows are going in both directions, if it's a function that has arrows, you know it's negative infinity. Oh, that is not an infinity sign. That is an 8. Negative infinity to infinity. The range, what's the lowest it goes? Negative infinity, because we always go bottom to up. And then what's the highest y value? 4. And since it touches it, it's going to be a graph. We know, we know we're always reading it left to right. So from here, all the way up to here, it's increasing, right? Because we read a graph left to right. So it's increasing when x is less than your axis of symmetry, 3. So all these x's, the y's are increasing. When x is greater than 3, we can see all the y values are decreasing. And is this a positive Patricia or negative Nancy?
Negative Nancy.
Negative, so it's down. So I know that's kind of a lot of work for each question, but we're trying to bring everything together just using your tables. Does that make sense? Cool. So you guys are going to be using or doing the next couple, but before that, I want to make sure you guys know how to do it. My graph's on here. Yeah, I'll have you guys do that as a ticket inventory tomorrow because the graphs look super funky on here. But you guys can just practice on this packet. Do you want me to show you what the Delta Math homework looks like?
Yes, ma'am.
Okay. I should have plugged this in. So the Delta Math looks like this. No, it doesn't look like that. And it's 5.3. I know. And so this is what it looks like graphing. So you can just put it in your calculator, and they just want you to graph 5 points, including the x-intercepts and the vertex. So you would put it in your calculator in your table, and you would graph what it looks like. So if this was my graph, I'm just doing a random one, it's wrong, then that's what I would put. But you could just put the points, put it in your calculator so you could see exactly what it looks like. Quadratic functions level 1, you can either put it in your table, or all you're doing, they want you to just plug it in for x and solve. So you could put it in parentheses and plug it in for x and solve, or you could type this in your table, and when x is -7, they want to know what the y is. Same thing with the next one. So they want you to type that in and find when x is -4, what's the y. Does that make sense? You can't, but I will give you time if you don't finish it in class. I'll give you time to use it tomorrow or the next day. Yeah, don't take it home though.
Or if you need to come back during extended learning, or not extended learning, what's it called here? Guided study. It's extended learning in my other school. But if you need to come back